Okay, so how did I get these nice values of t to plug into the function? Well, here's how you proceed to find that. You're going to find the period. And the period is 2 pi over b. In this case, that's 2 pi over 4, which is pi over 2. Okay. I'm going to find something that I'm going to call a starting point, because I haven't found a better name yet. Now, the word start is a little misleading, because you remember these sine and cosine waves, they go on forever in both directions. There really is no beginning and there is no end. But start is going to be one of the first places that I graph. I start when bt plus c equals 0. For this particular problem, that means when 4t plus pi over 6 equals 0. So I'm going to do some algebra from here, maybe obnoxiously showing too many steps. I'm going to, solving this for t, add negative pi over 6 to both sides, giving me that 4t equals negative pi over 6. And then to solve this, you were probably used to just putting a 4 underneath, but I'm going to get a little bit more sophisticated. Instead of dividing by 4, I'm going to think of this as multiplying by 1/4 on both sides. It's really the same thing as dividing both sides by 4. Gives you the same result, but a little bit prettier. Okay, so 1/4 times 4 makes 1. This makes t. That's no accident. I chose this to call that 4 and make that a nice t. Meanwhile, negative pi over 24. That's my starting point. Negative pi over 24. Okay, we gave you the period. And what I should have done right after that, before I did this, but it's all right, is found what is a quarter period. Because remember, those key points happen every quarter period. So a quarter period is 1/4 of, in this case, pi over 2, which makes pi over 8. So I'm starting at negative pi over 24, and I'm going to step up by pi over 8. And you know what? It's convenient to have these have the same denominator. So pi over 8 and 3 pi over 24 are mathematically equivalent, but now I've got the same denominator. Okay. So coming back over here, here's how I got these. I started actually here. I'm going to start at negative pi over 24. And I'm going to keep adding 3 pi over 24. So all my denominators are going to still be pi over 24. They're all going to have pi. And all I'm really doing is increasing this part of the coefficient by 3. So from negative 1, add 3, add 3 again, add 3 again, add 3 again, add 3 again. Going backwards, subtract 3, subtract 3. So these were the numbers, and I gave you these. I had you rewrite them with the denominator of 24, but this got me on my way to making sure that this was going to spit out those nice values of 4t plus pi over 6. So what did I want? Well, one of the things I want is I like to plug 0 into my sine function. So my starting point was when this guy, we call it the argument for sine, 4t plus pi over 6 was going to be 0. And I figured out the value of t that would do that. I figured out the period. This formula holds. It's 2 pi divided by b. In this case, 2 pi divided by 4, or pi over 2. It's good to know a quarter period because the key things happened every quarter period. Every quarter period, so 1/4 times the period, pi over 2, is pi over 8. Since I was going to keep adding this on, I got a common denominator, 3 pi over 24. So where did I start? Negative pi over 24. Where did I get the next key values? I kept adding on 3 pi over 24, 3 pi over 24, 3 pi over 24, to keep adding that on to get these key values. And then as you saw the table unfold, these all became my nice pretty multiples of pi over 2. When I plugged them into sine, I got my zeros, ones, and negative ones, which were then easy to plug into negative 3 times something nice plus 5.